Okay, welcome to the video for FP4 and FP5, difference of squares and perfect squared trinomials. Okay, our objective for factoring polynomials, objective 4 is I will be able to recognize and factor difference of squares binomials as well as multiply them back together. All right, so let's take a look at this. We have x squared minus 9. So the first thing that I want to do when I see something like this and it's time to factor is I want to see if there's a greatest common factor between my two terms. And there actually isn't. There's a 9 here, but there isn't a number here, and there's an x here, but there is not an x there. So there is no GCF for this. So now I'm going to try a different strategy. I'm going to use the I-bar method, but that is only used for trinomials. So I'm going to expand this. I'm going to put a middle term in there so that way I can factor it. So x squared plus, what could my middle term be with x so that it doesn't actually change the value of my binomial? Well, I could have plus 0x because 0 times x is 0, and then once I add that in, it doesn't actually change anything. Minus 9. So now, when I go to set up my I-bar, a times c would be negative 9 on the top and 0 on the bottom. Okay, now I'm going to urge you here to pause the video and make this more interactive rather than just following along. But pause the video and see if you can come up with the factored trinomial here. So come up with a set of binomials that this should factor into. Okay, so hopefully you've done that. And if we list our factors here, 1 and 9, well, one of them, even if I made them negative, would multiply to 9, but they're definitely not going to add or subtract to 0. So if I do negative 3 and a positive 3, well, negative 3 times positive 3 does equal negative 9, and negative 3 plus 3 is going to get that 0 in the middle there. So I can make this x minus 3 and x plus 3. So there it is factored. I'm going to multiply it out really quick to see what happens. What happens in the middle? Does that middle term get canceled out? So I'm going to multiply my front two terms together, and I get x squared. I'm using FOIL. My outer two terms gives me a positive 3x. Inner two terms, negative 3x. And then last two terms, negative 3 times positive 3 is going to give me negative 9. So positive 3x minus 3x, well, these end up just canceling out, and so I'm back to x squared minus 9, which is what I started off with. So perfect. So what this is, when you see this, is a perfect square. Or I'm sorry, not perfect square, difference of squares. Okay, so that's what this front page is about. So how do we recognize the difference of squares? Well, it is a binomial. That's number one. It can only have two terms. So binomial means two terms. Both of the terms are perfect squares. And if you don't remember what perfect squares is, you're going to want to write this down. A perfect square is when the square root is a whole number. So no fractions or decimal points and no negatives. And then the last thing for it to be a difference of squares, well, the word difference means that there must be a minus sign between the two terms. Okay, otherwise it's not a difference of squares. So we're going to jump into some examples here. Are the following examples of difference of squares? Well, it needs to be a binomial. If we just glance down here, they're all binomials that I gave you. And now the two terms need to be perfect squares. So x squared is a perfect square, because if I take the square root, it would just be x. And 4 is a perfect square. And there's a minus sign between the two. So this one, yes. And we're going to get into factoring them in just a little bit. 4 is a perfect square. If you have more than just the x, if you have multiple variables or numbers, you have to just make sure that every single variable or number in the term is a perfect square. So 4 is a perfect square. X squared is a perfect square. We do have a subtract, or we do have a minus sign in the middle, and then 9 is a perfect square. So this one's also going to be yes. Okay, here we have a 9, that's a perfect square. X squared is a perfect square. 3 is not a perfect square. We could factor this using the GCF, but because of this is going to be no, because this is not a perfect square. Coming on to this next one here, we have a couple problems here. Not only is 5 not a perfect square, but we also have a plus in the middle here. So this is not a difference of squares. Okay, here we have multiple parts to our term. So we have a 9, that's a perfect square. X squared is a perfect square. 36 is a perfect square. And y squared is a perfect square. And we have the minus sign, so yes, this is a difference of squares. All right, so now we're actually going to get into factoring them. So first you're going to, once you know it's a difference of squares, you're going to find the square root of each term. So let's go ahead and do that here. We have the square root of 4 is 2, the square root of x squared is x, and the square root of 9 is 3. So that's the square root of the term on the left, and that's the square root of the term on the right. Put into 2 sets of parentheses. So we have 2x, and 3, and 3. And then last, put a minus sign in one and an addition sign in the other. So this one gets minus, plus. It doesn't matter which one gets the minus and which one gets the plus, because when we multiply together, order doesn't matter, but there we go. All right, let's do some examples here. So I'm going to take the square root. I'm actually just going to go ahead. I can see that they're difference of squares. We already checked that above. So I'm going to go ahead and set it up like this, plus and minus. Now it's just a matter of taking the square root, 3x, and then the square root of 16 is 4. Okay, again, check that this is a difference of squares, but these are both perfect squares. This is a perfect square, and I have a subtraction sign in the middle, so I'm going to go ahead and set it up, plus, minus, and I get 9x, and then the square root of 49 is 7. Okay, coming here, I have perfect square, not a perfect square. Can I still factor this? Yeah, I can still factor this. It's just not a difference of squares. So I'm going to factor out the GCF, which is 3. And then I divide each term by 3, and I'm going to get 3x squared minus 1. So I was still able to factor this, just not using difference of squares. Okay, how about this one? Well, we already discovered above it's not a difference of squares. I'm also not seeing a GCF here. Okay, there's nothing that goes into both 16 and 5. So this one's just plain not factorable. I'm just going to leave it as it is. All right, this last one, we have a 4 here. So you might think, well, maybe that's not a difference of squares, but I actually can take the square root here. And let me show you what we would end up with. So the square root of 9 is 3. The square root of x squared is x. And then if I want to find the square root, I can just actually take the square root of 4, and this would be y squared. If I were to multiply those back together, you would see that y squared times negative y squared is going to give me negative y to the 4th, because I'd have to multiply these exponents together. All right, so we kind of want to know this stuff frontwards and backwards, meaning when we're given difference of squares, we can quickly multiply them back together without foiling everything. So I see right here that I have the same terms in the left and in the right of each parentheses, and then one's plus and one's minus. So rather than foiling it all together, I'm just going to go, okay, this is x squared, and this is going to be minus, and now 6. So you can see how this turned into, whoops, I messed that up. I have to square it. Let's try that again. So you could FOIL it all together like we did at the very top here, and then you see that the middle terms cancel out. Or if you recognize right away that it's a factored difference of squares, because you're seeing the same numbers and variables repeated with just a plus and a minus sign, then just go ahead and square this one, square that one, and stick a negative between it. Same here. I'm going to square this one. I'm going to square this one. So 3 squared is 9, y squared is y squared, and then I just need to stick a negative sign between the two of them. All right, I've left some examples for you to try, so try these before you move on to the back to watch the rest of these notes. Let's see if you can first factor it using difference of squares or not difference of squares, if the case may be, if you have another way of factoring it. And then this last one is for you to try to multiply back together without using the FOIL or the box method. Okay, objective 5 for factoring polynomials. I will be able to recognize and factor perfect square trinomials as well as multiply them back together. All right, so here we go. We have a trinomial. So let's just use the I-bar method and factor this out. So 1 times 9 is 9, and I get 6 on the bottom here. And now go ahead and try to factor this. Pause the video and then rejoin me when you're ready. Okay, so factors of 9, I'm coming up with 1 and 9 and 3 and 3. Well, it looks like 3 and 3 are the ones that are going to work here. So x, and they're both positive, plus 3 times x plus 3. All right, but we have a special name here, perfect square trinomials. Well, if I wanted to multiply these together, I could FOIL them together, or I could just, if I'm multiplying the same thing times itself, like for instance, 2 times 2 would be 4, or 2 squared. X times x would be x squared. So x plus 3 times x plus 3 is actually going to be x plus 3 squared. Okay, so this is actually factored. And this is fine. This is a correct answer, but we're going to look at perfect square trinomials because they come up a lot in math. You don't need to factor them in any special way, but it is really good to be able to recognize them. Okay, so we want to recognize them, so how do we recognize them? Well, the first and last terms are perfect squares. And this should actually say trinomial. I'll fix that on yours. But how can I recognize a perfect square trinomial? Well, the first and last terms are perfect squares. So here we go. X squared is a perfect square, and 9 is a perfect square. Now the middle term, and I'm going to color code this here, is 2 times the square root of the first term times the square root of the last term. So let's give that a try here. All right, so the square root of the first term is x, and the square root of the last term is 3, and then we need to multiply them both by 2. Well, 2 times 3 is 6 times x. That does, in fact, equal the middle term here. Okay, so that's where this middle term comes from. Okay, only the middle term can be negative, and we'll explore that in a little bit, but only the middle term can possibly be negative. And you're going to use the middle sign in the factored binomial. Okay, so whatever the sign is here is what's going to end up in your parentheses in the end, and we'll give some problems a try here so you can see what that looks like. Okay, so is this an example of a perfect square trinomial? Well, the first and the last are perfect squares. And then is this middle term the square root of the first and last times 2? Let's find out. The square root of, well, first we'll do 2 times the square root of the first one is x times the square root of the last one is 4. Well, 2 times 4 does equal 8x. And now we're just going to factor it. Well, all I need to do is take the square root of the first and take the square root of the last and use the sign from the middle, which is plus, and square it. I didn't give you some steps on that. If you want to write some steps out here about how to do this, I'm going to do another one, and then you can just write the steps out here. So first step, to make sure that it is, in fact, a perfect square trinomial. So if I take 2 times the square root of the first one, which is x, times the square root of the last one, which is 4, they should multiply to the middle one. And that works, and I can only have a negative on the middle term. Well, I have a negative on the middle term. So to actually factor it, really basic steps out here, but we're going to take the square root of the first and the square root of the last, use the sign of the middle, which is a negative, and then lastly, we're going to square the whole big set here. Okay, how about this last one? Well, I can take the square root of the first one. It would be x. And when I go to take the square root of the last term, well, here's the problem. I can't actually take the square root of a negative 16. Front, we did have difference of squares, so we did have a negative in the middle there, but that's just a different situation. But I can't actually take the square root of this. Okay, and if I try to factor this or turn it into perfect square binomial, let's do that really quick and see what happens. What I think it might be, right, would be either x minus 4 squared or x plus 4 squared. And you see that these were already used over here. X plus 4 squared, if you took the time to multiply this out, and guys, here's a really important thing that I should bring up. You cannot multiply this out just by distributing the 2. That is a huge no-no. I see kids do it all the way up to calculus. We do not want to do that. If we have a binomial, to multiply it out, you actually have to longhand go x plus 4 times x plus 4, and then front would be x squared, outer would be 4x, inner would be 4x, and last would be 16. When I combine these two, I get x squared plus 8x plus 16. Very different than putting it as x squared plus 4 squared. All right, so you see that that's that one. If I were to multiply these back together, I now get x squared minus 4x, and I'm running out of room, plus 16. When I combine those, I'm going to end up with this. This can't be either of these two. Because if I want to take the square root of 16, I can't. I can't take the square root of negative 16. All right, so what could I do instead? Well, I could try to factor this using the I-bar method. So I'm going to erase these here and move in here and factor using the I-bar method. So negative 16 at the top and positive 8 at the bottom. My factors, we could try 2 and 8. Not going to add or subtract 2, 8. 4 and 4. Well, I'm going to need a negative in there someplace. If I make one of them negative, that multiplies to negative 16. But it's not going to add to 8. Okay? And no other factors are going to work. So this one is actually not factorable. So all of this was just to show you that the only way for it to be a perfect square trinomial is that negative can only be on the middle term here. All right, so multiply the following back together. Now this is going to be useful later on in math because there's going to be lots of situations where you're given a binomial that's squared, and if you can just remember how to quickly multiply it back together rather than longhand, it'll be a little bit faster for you. Well, to multiply it together, we know that the x is going to be x squared. The 3 is going to be 9. The sign on the middle term's right there. This one's always going to be positive. The sign on the middle term's right there. And now how do we find this one? Well, we need to take the square roots, which we already have here, multiply them together. So we're just going to do x times 3 and then times that by 2. So 2 times 3 times x. And I get 6x for the middle term. Okay, let's try that again here. We're going to square the first one, so 4x squared. We're going to square the last one, so 25. This has to be positive. This one, because it's negative, our middle term's going to be negative. And now I'm just going to take 2 times 2x times 5 to find that middle term. So 2 times 2 is 4, 4 times 5 is 20, so we get 20x. All right, last one here. I threw this in because it's something that we've been doing a lot in calculus, is this comes up, and you need to be able to multiply it back together. And this is a tiny step of a much larger problem. So if you, over the next few years, get used to multiplying perfect square trinomials back together, then doing this just becomes a very simple calculation. So first term's going to be a squared, last term's going to be h squared. Positive here because this one's always positive. Middle term is going to be positive. And now I have 2 times a times h to get that middle term. So 2ah. Okay, that's it. That's it for the notes part. Please make sure you give these problems a try. Thanks for watching.